Okay, good evening, my dear students. So this is the 7th module on Physics 2. And then this is going to be about electrical resistance. Okay? So from our past modules, we know that potential difference, there's a potential difference between, or across, I should say, points A and H. No? At point A, that's the high potential point, and then at point H, that's the low potential point, the negative terminal. And because of this potential difference, because of this voltage difference, the positive charges will naturally move from the high potential to the low potential, meaning it will move from point A to point H. Okay, it will move throughout the external circuit where the electrical loads, such as the light bulbs here, are located as well. Okay. So in a way, or in a sense, it's encouraging flow of charge. Without potential difference, there won't be flow of charges here or throughout the external circuit from the positive to the negative terminal. And then we also discussed that actually the charges are not moving in a straight path. Okay, charges are actually parang colliding, di ba? They are colliding with the fixed atoms of the wire. So parang nagiging zigzag or parang back and forth yung kanilang movement because of this collisions with the atoms of the wire. So because of these collisions, very slow ang movement ng charges from point A to point B, or from the positive to the negative terminal. It would take them some time to get from one point to another. Okay, so if voltage or potential difference encourages flow of charges, this collisions with the atoms discourages the flow of charges. We also studied about voltage gains, diba? Voltage gains or voltage boost coming from the battery as it is moving the charges from the negative to the positive terminal. And then all of the voltage gains or the energy gains from the battery, all of them will be consumed as the charge is moving from, or is moving throughout the external circuit, diba? Such that at this point it's already at 0 joules energy, or it's already at the zero low potential point. Okay, so here obviously most of the voltage drops, energy loss happens across the diba, the electrical loads, as they should be, kasi diba, you want the electrical energy to be consumed, transformed into heat and then light, more importantly light energy. So you can see the big drops from B to C, D to E, and then F and J, across F and J. So yung wires, as the charges are moving along the wire, there's some losses then, no, in energy because of the collisions, diba? So there are little losses in electrical energy then. That's why you can see here that medyo may konting difference. There's a slight, hindi pantay yung A and B. Okay, there's a slight, very slight small drop in the diagram, and that's actually evident kapag nag-iinit na yung wires ng wire, diba? As a side effect of the collision. So these drops are actually caused by resistances. The resistance, that's the term that we will use dun sa collision that are happening between the charges and the atoms of the wire material. Okay, the resistance of that material. So obviously here, it is the resistance that's causing the voltage drops, diba? So the resistance is greatest at across or dito sa ating mga electrical loads. Okay, the resistance is highest on that point, and then much smaller are the resistance, as they should be, of the wires, kasi their purpose is to transport, diba, the charges to the load. So resistance causes voltage drops and then causes the charges to slow down, diba? So the larger the resistance, the lower the current that will be in the circuit. That sounds like a bad thing, diba? Because it's hindering the flow of charge. But it actually depends on how you see it. For example, if you have a toaster, diba? So if that toaster has some resistance, it will oppose the flow of charges. Ibig sabihin, hindi agad-agad makadaan yung charges along the wires doon sa ating toaster, bread toaster, oven toaster. Because of the collision, that will cause some parts to heat up, diba? Which is the purpose. Because you want to toast your bread. You want to boil your water in a heater. In our simple circuit, where we use light bulbs, incandescent lamps, for example, the filament are actually composed of a very, very thin wire that can get hot easily. So it will get so hot that it will actually glow, diba? Yun yung ilaw na ginagamit mo. So resistance is not such a bad thing, okay? So resistance is affected by factors, of course. One of the factors is length, the total length of the wire. So syempre, diba, resistance is the collision that's happening between charges and the atoms of the wire. Syempre, the longer the wire, the higher the chances of collisions happening, the more collisions that will happen. So if you have longer wire, that's actually means that that wire has a greater resistance as compared to a shorter wire. Another one is the cross-sectional area. Cross-section, ito. Yung papasukan ng charges, diba? So, syempre, pag mas malaki yung area, mas malawang siya, more charges can be accommodated, diba? And that will lead to lesser collisions. So, larger the cross-sectional area, lower the resistance. And then, the longer the wire, the higher the resistance of that wire. That's the relationship. It's also affected, resistance is also affected by the type of material, okay, ng wire mo. So, parang materials are not created equally in terms of their resistance or their ability to conduct charges or to let charges flow through them. So you can see the list of materials here. You have silver, copper, gold, and then on the other side, glass, rubber, polystyrene. Okay, so you will also observe that these are mainly conductors and metals. These are non-metals and are insulators. So also affected by the material. We can see also that we have some resistivity values here. So here, ang exponent niya ay negative times 10 to the negative 8 here for silver. And then here, times 10 to the positive 14. So definitely, the values of resistivity are much, much larger here. And here are much, much smaller. Ibig sabihin, maliit ang resistivity or maliit ang resistance na ina-offer ng mga conductor. Meanwhile, malaking resistance yung ina-offer ng mga insulators. Translation, that also means that charges can easily flow in materials, in these types of material above. So, mas magaling siyang magpadaloy ng charges. So, silver is the most conductive, diba? The lesser its resistance, the larger the current. But we don't use silver in our power lines kasi syempre, well, it's expensive. So, we use copper instead. Okay? Aluminum also. We can compute for, or we have an equation for resistance kung saan makikita din natin yung mga factors affecting it. So, R, resistance, by the way, its unit is ohms, and if ampere is A, ohms is omega. I think you already saw that Greek symbol before. This is rho. This is the resistivity. This is ohms times meter. Here, ohm times meter. L is the length. That's in meter. A, that's the cross-sectional area, meter squared. Yes, meter squared. Okay. So since this is okay, rho is in meter, ohms times meter, times length is in meter, area is in meter squared. That should cancel out one of the meters, and this one will be cancelled out. You are left out with ohms, which is the unit for resistance. You can also see here the relationship, diba? The longer the wire, the higher the resistance. The larger the cross-sectional area, the lower the resistance. And here is your trump card because that depends on the value of the material. The higher this is, also, the higher the resistivity value, such as that of the rubber, the higher the resistance as well. Okay. This is applicable for if we have a cylindrical object, a wire, di ba? Paano ko kukumpitin yung kanyang cross-sectional area? If I have a cylinder, ang kanyang cross-section is circle, di ba? That means pi r squared or pi d squared over 4. Pi over 4 times d squared. That's how you will compute for the area. Usually you will be using this because most of the wire will be given in terms of distance. What did I say? Diameter. Okay.